This is a review of Unit 1 for the final exam of ENGR 201. For number 1, R of t equals 1/2 t squared I plus 2 root 2 over 3 t to the 3 halves j plus t k, where t is greater than 1. So now we need to find all these different vectors and other physics terms. So v of t is just a derivative of r of t, so it's going to be 2 times 1/2 t, so it's going to be ti plus 3 halves times 2 root 2 over 3, so it's going to become square root of 2 t to the 1/2 plus j plus k. And we don't need to write this down yet. We only need to write that down when we need it to justify a certain answer. So now we need to find the magnitude or speed of for this function. So it's going to be the square root of t squared plus square root of 2 squared t to the 1/2 squared plus 1 squared. And this will equal the square root of t squared plus 2t plus 1. And if you notice, we can expand this or factor it. So then it becomes t plus 1 squared, which equals the absolute value of t plus 1. Now, since t is greater than equal to 1, we know that we can make this equal to t plus 1 since t is greater or equal to 1. Now, a of t is a sub t, so this is the tangential acceleration. So this is the acceleration. So this would be the derivative of speed. So because speed is your tangential magnitude, and we want to be able to and this is how you calculate is by taking the derivative of the magnitude of v of t. So this will just equal 1 because you're taking the derivative of t plus 1. Now a of t is the derivative of the vector velocity. So this will just be I plus square root of 2 over 2 t to the negative 1/2 j plus 0 k. You don't have to leave that k there. You can just make it gone. Now, a to the n, there's two different ways to calculate a to the n. There's v squared over r, or square root of magnitude of a of t squared minus a sub t squared. Since we don't have r, we have to use that second equation. Oh, that's magnitude, by the way. So then magnitude a sub t would be the square root of 1 plus, that would be 1/2 over t minus 1. So these 1's will cancel. So this will become equal to the square root of 1 over 2t, or 1 over square root of 2t to the 1/2. So that's our normal acceleration. This is our tangential acceleration. So together, when you add those, you can see that we have both the I here, and this is the j term here. So it just so happened that the a of t is in the I direction, a sub n is in the j direction. So now this is for an oscillating circle. So again, they'll always prompt you what to do. So in here you have y equals to the 1/4 x to the 4th. Take derivative of that. It's going to be x cubed. Now plug that in for 1. It's just 1. Y double prime is going to be 3x squared. Plug in 1 for that. You get just 3. Now we're finding k for the point 1, 1/4. And the equation for this is the magnitude of y double prime over 1 plus y prime squared to the 3 halves. I do not believe you need to memorize this, but it's always good to just know what to do so you don't have to spend time looking for an equation. So y double prime is going to be 3, magnitude of 3, over 1 plus y prime, or y prime is 1, squared to 3 halves. So this will just equal 3 over 2 root 2, or 2 to 3 halves, however which way you want to put it. And while we're at it, I'm just going to make a side note here that rho equals to 1 over k, which equals to 2 root 2 over 3. So now I need to find the unit internormal. So the unit internormal is going to be n hat, which equals plus or minus I plus mmj, where mn is the slope of what is normal to the point. So and this is going to be in the direction of this from the point to the center. This is 1 plus mn squared to the 1 half. So y prime equals 1, which equals mt, which is the tangential slope. So what is tangent to that point at point 1/4, and this will equal this, and mn is going to be normal to the tangent, so it's going to be negative reciprocal 1 over mt, which will just equal negative 1. So this will equal plus or minus I minus j over, this is going to be negative 1 squared, so just 1, and it's going to, and plus 1, 2 to the 1 half, square root of 2. Now we need to figure out which direction is it going to be, plus or minus. So if we're looking at the curve, it's concave up. So we know that our center is going to be somewhere up here. So it's concave up and it has a positive slope. So it means that the center is going to most likely be above it and to the left. So this is going to be our our vector that is in direction of the normal from the point to the center. This is the center. So then that means we are going to go into negative I direction or the positive j direction. Either way you want to look at it. You only need to look at one. So if we know we're going to go into negative j direction, or sorry, negative I direction, we don't need to pick the negative, or if we need to know that you're going to positive j direction, negative makes it a positive j. And so that's our unit internormal. Now we need to find the equation for the osculating circle. So I'm going to go ahead and draw the other vectors here. So there's the vector from origin to point. There's the one I just drew, which is point to center, and then what we're going for is origin to center. So that's the vector we really care about, because that's what's going to give us our center for our circle. So that's how we can then find the equation of the osculating circle. So origin, point. Okay. So we know that OP, I'm going to do this in a different color. So OP plus PC equals OC. So makes sense. Go this way, equals that way. All right, so now we need to substitute PC with rho in hat. The reason for this is because Row, because we don't, in order to know this vector, we need to know the row, which is going to be the magnitude of our vector, and n hat is our direction. So row gives us our magnitude, and n hat gives us our direction, so we know the vector from point to center. So now what we have to do is substitute in the vectors for all of these to solve for origin to center. So this will equal OP, which is just origin to point, which is essentially putting your x term, your x point for your I and your y point for your j. So I plus 1/4 j plus row n hat. So row, remember, we had that was 2 root 2 over 3. And then n hat, we chose the negative version of this. So it's going to become negative I plus j over square root of 2, which is nice because it cancels out the root 2's. And now we can go ahead and solve for it. OC, so we can only combine the i's together. So we're going to have 1. This is going to become a minus 2/3 I, because I took the coefficient of this term and the coefficient for this term and combined them, since 2 over 3 is going to be distributed to both the I and the j. And then I'm going to have plus 1/4. And we're going to also have we're going to have a plus 2/3 this time for the j. So then we can combine each. We have I over 3. Then plus, we need to find a common denominator. So it's going to be 12. So this is going to become 3/12. This is going to become 8/12. So we're going to get 11/12 j. And sometimes they would like it if you factored out stuff, but you can leave it as just that, since they're not specifically asking for point to center vector. But now we know that this is going to be our center. So this implies our center is then 1/3 11/12, which makes sense because it's a little bit less than 1 because we're going in the negative I direction, and it's a little bit greater than 1/4 because we're going in the positive j direction. So now we can then solve for the equation of our circle, which is going to be x minus our x point, or h, however which way you want to understand it. So x minus h squared plus y minus k squared. And this is going to equal r squared, in this case rho squared, which is 2 root 2 over 3 squared. And this is the same as square root of 8. So we can square square root of 8, then we'll have 8 over 9. So then this is our equation for our oscillating circle. All right, this is pretty much a good idea of what you need to know for Unit 1. I hope this helps. Good luck for your test.